Okay, hi guys, I am back. So happy Monday. This is our June week one. Okay, this is our first lesson of June. How are you guys doing? Happy holidays, by the way. Okay. Hi Sinteng, is this how I say your name? Welcome. This is our June week one. I don't know whether you have the notes. Okay, are you a new student? Because if you are, then I am afraid we haven't finished the old notes yet. Right? Yes. Hi, hello to you. What school are you from, by the way? What school are you from? It's a holiday today, lah, huh? That's why no one came. Where's the other four? Stella Academy, I see. Right. Just a question. Do you guys follow the Cambridge textbook? Do you guys follow the Cambridge textbook? Because I follow the Cambridge textbook, right? Because some schools they don't, some school they do. So I also don't know, lah, huh? Right? Because I follow the penguin book. You know, there's a penguin on your cover one. Is it a penguin? The Cambridge book, lah, okay, the Cambridge book. So my chapters will follow the Cambridge chapters, right? So I don't know where your school currently is because I am still at element and compound, right? Haven't learned much of what we learned here. Yeah, because because I just began. Okay, don't worry, don't worry. Today will be better. Today will be better because last week we just learned this, right? Something if you haven't learned this, please let me know. I'll try to slow down. Right. So guys, as I said last week, we have mentioned what is atom. Atom is the simplest thing in the world. All right. Just think of them. Just think of your world is made of Lego. Okay, it's made of Lego. If you take that Lego to the smallest piece that you cannot take it anymore, right? If you take it apart to a point that you cannot take it apart anymore, it's already the smallest. You know that block of Lego that is the smallest. You cannot break it down anymore. That is our atom. Okay, that is our atom. Atom means cannot be divided, right? And atoms they make up elements. All right. If something is only made of one type of atom, we call them an element, right? Like for example, pure gold. Pure gold. Inside a piece of pure gold, there's only gold atoms inside. If you get what I mean, right? That means if I have a piece of gold, I zoom into to the gold, I only see gold atoms inside, no other atoms. That's why I call it pure gold, right? So atoms, they will form element, if you get what I mean, right? So like you see, iron is an element because inside a piece of iron, you only see iron atoms, right? There's only one type of atom here, so you get an element. Iron is an element, okay? You guys okay, huh? You guys okay, huh? If you're not okay, please let me know, huh? I will try to slow down, right? And scientists or chemists, they have put all the elements into this thing called the periodic table of elements, right? You have 118 types of elements in the world, right? In the world, right? You have 118 types of Lego in the world, if you put it that way, right? And this periodic table, do not memorize this. I have said this before and I will say it again. Do not memorize this. You just need to know coming down is what we call group. Okay, this is group 1, group 2, group 3, group 4, group 5, group 7, all the way until we reach group 18. Okay, and going across is what we call period. Period 1, period 2, period 3, period 4, period 5. These are what we call periods. Okay, so this is like your maths lah, like when you're looking at coordinates. When you're looking at coordinates. Okay. Arian is okay? Is Arian okay? Is Arian okay? Sinto, have you learned this before? Have you learned this before? Not sure where's your school currently lah, huh? Right? I mean, oh, you have learned this already? You finished this chapter already? By the way, what intake are you? Some they are in January intake, some is in um June intake. So you have learned this already? You have learned this already. Okay, so like I said last week, if you were to describe aluminium, if someone were to ask you where is aluminium, you can say aluminium is at group 13, is at period 3. This is like your XY axis when you're referring to your maths, right? Okay, so coordinate X is 13, coordinate Y is 3, so yeah, really easy stuff. Okay, and as I mentioned last week, all these are symbols. All these are symbols. You are not using it right now. Okay, you're not using the symbols right now. You'll be doing so in year 10. All right, so we talk about the basics first. Maybe next year, if I have the chance, maybe we'll talk a little bit about the symbols. Right. Anyway, so the periodic table is read from left to right, top to bottom, just like how you read a book. When you're reading a piece of paper, when you're reading something, you always read from the top left all the way to the left, to the right, and all the way to the bottom. You read it this way, isn't it? You read it this way, isn't it? So this is how you do it. It's the same. It's the same as you reading a book. You read the same, right? And from left to right and top to bottom, the mass of atom increase. As I go more to the left, sorry, more to the right and more to the bottom, the heavier I get. Okay, so this is the lightest, second lightest, third, fourth, fifth, sixth, seven, eight, nine, 10, and all the way. So by this logic, this guy is the fattiest. Okay, is the fattest fatty here. This is the heaviest guy. Right? Guys, I have a question here. What are these? What are these? Why are there 2 rows of stuff down there? What are these? What are these? Has any of you learned it in school? Has any of your teacher told you what are these 2 things doing here? What are they doing here? Just to let you know, these metals, they should be here. Right? Can you see lanthanides and actinoids? They should be here. You might say, hey, sir, why don't we just insert this thing here? I mean, you can, but the periodic table will look freaking long, right? You need like 2 pieces of paper to fit this thing. So it's kind of stupid. And we don't really bother with these things. So we just kind of separate them out. They are like these weird elements that we don't mess with. They're just weird, right? In fact, we just call them rare earth. Have you heard of this before? Have you heard of this before? Rare earth are things we use in electronics. In electronics, your phones, your PC, your any electronic stuff lah. Even your car has electronic stuff, right? So most of the electronic stuff, they will use things from here. And what are they? You don't need to know because it's not really your concern, right? Even if you ask me, sir, what is DY? I will say I don't know. What the hell is Californium? California, I know lah. Californium, I don't know. Right? So don't ask me. You can go read on Wikipedia yourself. I couldn't be bothered because they are stuffs you don't mess with. Even when I was in A levels, guys, I was in A levels and I was after that in engineering. We don't mess with this. Okay, we don't mess with these because they just don't. They are not that useful. All right, you get what I mean? Right, so elements that are found naturally in Earth's crust, guys. So these are the things found in Earth's crust from the most abundant to the least. Not to say the least lah, but these are the few most common ones lah. You find the most oxygen in the Earth's crust. You might say, huh, sir, inside our Earth got oxygen one got oxygen one They have oxygen, but in the form of compound. Okay, let's talk about compound, shall we? Let's talk about compound. Have you guys learned this before? Do you know what is a compound? Do you know what is a compound? When 2 elements, they combine together, you get a compound. Right? You get a compound. In this case, we say like water. Water. You see? You see hydrogen is an element, right? Okay, hydrogen is an element. Oxygen is also another element. When you combine them chemically, the keyword here is chemically, guys. When they become friends, there's a friendship, isn't it? There's a friendship, we call them compound. All right, in this case, guys, what do you get when you add hydrogen to oxygen? This is a very easy question. What happens when you add hydrogen to oxygen? What do you get? What do you get? What is something that you use every day that has hydrogen and oxygen? Anyone? Are you guys having holiday today? I bet it is, right? I bet it is, right? Most of my students are having holiday today. So it's either they don't show up or they just kind of chill. Right, so what is hydrogen and oxygen? You will get water. So water is a compound. Can I? Can I? So the water you drink is H2O. Right? I'm sure you know this. H is the hydrogen, O is the oxygen. So they are a compound because they are elements married together. They become friends. See what analogy you want to use lah. You can say they become friends or they become married. Whatever, they form a bond. Okay, they form a bond. Okay, what is a bond? Okay, if I have the chance, I'll talk about that. That means they tie together. They are tied to each other. So when oxygen and hydrogen, they are tied to each other, they become water. Okay, they become water. So water is a compound. Water is a compound because a compound consists of two or more different elements combined chemically. Guys, two or more different elements combined chemically. Combined chemically means they become friends. Okay, or they get married. See, whatever it is lah. So in this case, if you look at water, do I have a water molecule here? So, oh no, I don't. Right, water, they look like this. Okay, water, they look like this. You have oxygen married to two hydrogen. So can you see they are friends? They got married. Okay, they just tie to each other already. So in this case, we call it a compound. We call it a compound. Right? If you mix sand and salt, guys, if you take a cup of sand and you take a cup of salt, you mix them together and you shake it, is that a compound? Is that a compound? When you shake salt and sand together, is it a compound? Anyone? Yes or no? Yes or no? When you shake sand and compound, is it a compound? No. Okay, it is what we call a mixture. We shall learn this maybe later. Right, so this is a compound. This is a compound. Oh, we have another one. Hello, Junyi. Good evening. Oh, you are here. Wow, I thought today holiday. There's only I still get 3 today. Wow. Sometimes my public holiday is 0. No one came because everyone is out. Right, so guys, compound, two or more elements combined chemically. It is produced from a chemical reaction. Since they are combined chemically, they have a chemical reaction. That means they become friends. Right? When two atoms of different elements combine together by chemical reaction, they form a bond. Okay, what is a bond, guys? What is a bond? Okay, let me come back to here. Okay, say this is water, right? This is water. Okay, this is H2O. Let me draw it nicer. Okay, this is H2O, right? Can you see the line? Can you see the line? This is what we call a bond. This is what we call a bond. A bond is like a relationship between atoms, right? You see, you and your mom has a relationship. Okay, you guys are related, right? You and your friend has a relationship, right? Not a romantic relationship, okay? I know what you're thinking. Sir, I thought I only have a relationship with my boyfriend or girlfriend. That is a romantic relationship, right? As long as you guys know each other, okay, you know your friend, you guys have a friendship. That is what we call a bond. Okay, that is what we call a bond. So whenever you have a bond, this is a compound. No bond, no compound. Like I said just now, if you mix sand and water together, they don't become friends. They have no bond, so they are not a compound. Okay, they are not a compound. By the way, this compound, right, is called 混合物 in Mandarin. Okay, if any of you learning in Mandarin here, 化合物 sorry, 这个叫做化合物，两个东西掺在一起，化学在一起 chemistry, chemical. So they are together, we call it compound. Right? So they form a bond between them. For example, when a sodium atom reacts with a chlorine atom, a bond is formed in between the two atoms and form a compound called sodium chloride. Right, let's say this is sodium. Right, sodium is Na, by the way. This is a sodium. when they get married to a chlorine, this is what we call sodium chloride, right? Sodium chloride. You see, sir, I thought the name is chlorine. Yeah, when they're single, they are chlorine. Now they are married, they are called chloride. Guys, do you know what is this? Guys, what is sodium chloride? Do you know what is sodium chloride? You should have learned this already, I think. Maybe last year, or someone has told you before, or if you attended my class, yes, okay. Sodium chloride, guys, is your salt. This is your salt, right? Table salt, the salt that you eat at home, that is your sodium chloride, right? They are sodium and chlorine married together, and they give it a salty taste, right? So that's the sodium chloride. Compound can be found naturally or be produced in laboratory. Do you remember those minerals you learned last year? Do you remember those minerals you learned last year? Those rocks and minerals you learned last year, right? Do you remember what is an aluminium oxide? Aluminium oxide is a compound because aluminium gets married to oxygen. Same goes to iron oxide, right? Guys, any of you here play Minecraft? Any of you here play Minecraft? You see this thing, what? It's called iron ore. It's called iron ore, right? I mean, if you play Minecraft, you understand lah. So iron ore, iron oxide, that means iron and oxygen, they marry together, they are a compound. Okay, and they look, your aluminium ore looks like this, your aluminium oxide looks like this, it just looks like a red color rock. Okay, this is, I know lah, for girls, this is like boring stuff lah, huh? I don't know why girls and chemistry don't mix very well. Physics is worse, right? So next, a compound is very different from the elements from which it's made. Okay, what do I mean? Usually a compound like water will be totally different from the elements. Totally different. As in, you see, hydrogen is a gas. Hydrogen is a gas. Oxygen is also a gas, right? But when you mix them together, they become a liquid. Water is a liquid, right? Water is a liquid and they look completely different, right? Completely different. Okay, I give you another example. I'll give you another example. Right. Have I mentioned here? Okay, let me finish this point. Once two different elements are bonded, they completely lose the properties of the individual elements. The compound has totally new properties. Right? Oh, I actually give you an example here. Guys, are you following so far? Are you following so far? Junie, you just came in. Are you following so far? Sinting, are you okay? Are you okay? Sinting, have you learned this in school already? Have you learned this in school already? Just to check with you, because every school they proceed at a different speed. Yes, you learn everything of this already? Like recently, or they finished it long ago? Some schools they are very funny one, or they will finish one chapter in bio, then they will jump to chemistry, they do one, and then they jump to physics, they do one. I have no idea why they do this lah. Okay, I just follow the numbers. Okay, I just follow my chapters and I'll go chapters by chapter. Okay, so do slow me down, if you have any question. So sodium is a very reactive metal, as you know. Right, guys, sodium is so reactive, it will catch fire when react with water. When you throw pure sodium into water, right? When you throw sodium into water, they will immediately explode, as you can see here, right? They are so damn freaking reactive. They touch water, they will explode. That's your sodium, right? And then chlorine is a very reactive gas. It bleaches and oxidizes many things it touches, right? So what about chlorine? Chlorine, guys, chlorine is this very dangerous gas that is yellow or green. Right, guys, this thing is so dangerous. Oh, you know your bleach? Do you know bleach? That bottle of Clorox at home, that bleach? Bleach is only 10% chlorine. 10 or 15% chlorine. It's already strong enough. We don't mess with chlorine. This is really poisonous. They used to use this in World War I to kill enemy soldiers. Right? So this is really dangerous. Okay, when it go into your lungs, okay, you'll be dead in minutes. Right? It's a very serious gas. Right? You see, sodium is such an explosive and dangerous thing. Chlorine is also a very dangerous thing. But somehow when you add them together, when you add them together, I see it is also fatal when inhaled. Chlorine is very fatal. However, sodium chloride, when they combine it together, or we call salt, is harmless when eaten. You see, you would think that according to our logic, you would think that okay, something really dangerous, reacting with something really dangerous, you will have double the danger, it will become more dangerous, isn't it? But no, salt is very harmless, right? You don't die eating salt. I mean, unless you eat like a bag of it, right? So salt, sodium chloride is two elements, sodium and chlorine, they are harmless, right? They just completely change. What I'm trying to say here is compound is very different from the elements, right? Even though you know all the elements in something, you just can't guess how do they behave because their elements could be very different. Like you see, water is two elements, hydrogen and oxygen, because water is H2O. This is NaCl, sodium chloride. Like rusted iron nail is iron and oxygen. Iron is Fe, oxygen is O. When they react together, they will become Fe2O3. We call it iron oxide. We call it iron oxide. So you see, iron is a silvery metal. Oxygen is a gas. When they react together, they just form this powdery brown color stuff we call rust. Okay, so iron oxide is a rust. It's the same. It's the scientific way we say rust. So that's your iron oxide, right? And of course, marble is made up of calcium, oxygen, and carbon. Right? Calcium, carbon, oxygen. In fact, marble is called calcium carbonate. When you add calcium, carbon, and oxygen together, you will get calcium carbonate. This is actually your metamorphic rock, if you remember. If you remember metamorphic rock, we learned this last year. You have three types of rock, right? We have igneous, we have sedimentary, and we have metamorphic, right? I like to call this baby rock, papa rock, and grandpa rock. If you remember what I mean, okay, grandpa is the oldest rock, which is marble. Right? You see, calcium is a metal, carbon is your pencil lead, oxygen is a gas, but when you mix them together, somehow they will just become marble. Right? So elements and their compound, it's totally different. Right? It's totally different. So this is what is happening right here. Right, about the naming. About the naming. When a metal reacts with a non-metal, the compound is named by the metal followed by the non-metal. We usually put the metal on the left side, right? And we put the non-metal on the right side, right? Why is that so? Why is that so? Because it's like, this is the format. Okay, you know in Mandarin we say 男左女右, right? You know what is 男左女右? Boys will go on the left side, girls will go on the right side. I don't know about you lah. It's like, okay, put it this way, guys will wear their watch on their left hand, girls will wear their watch on the right hand. Is it? I don't know lah. At least I wear mine on the left lah. Right? So 男左女右 lor. So 男生是 metal 嘛. Okay? Because metals are hard and tough. So boys are metals. Non-metals are soft. So girls are non-metals. So you see, we will put guys on the left side. Metal is the hard one. The tough one, left side. Girls are the soft one, right side. So 男左女右. Okay? Metal and non-metal. Right? Guys, I don't make the rules. I don't make the rules. This is what chemists decided. We should put the metal first, then we put the non-metal. Right? The non-metal is usually added with the suffix I. For example, when iron marries sulfur, you get iron sulfide. Sodium marries chlorine, you get chloride. Lead marries bromine, you get bromide. Right? It's usually the girl that changed the name. The boy doesn't change his name. Okay, the girl will change the name. It's the same thing, but it's the same thing, but right. Let's say if you are Miss Tan, Let's say you are Miss Tan, you get married to Mr. Lee, you are Mrs. Lee. You get what I mean? You get what I mean? They will refer to your mom with your dad's surname, right? They don't refer to your dad as your mom's surname. What? It's usually the woman who changed the name, right? I mean, this is a tradition that we follow lah. So it's the same thing here, right? We just use the guy's name. So it's usually the girl that changes the name. So whenever you see "ide" means they're married, Sulfide means the sulfur is married. Chloride means the chlorine is married. Bromide means the iodine, the bromine is married, right? Same goes to oxide lah. Oxide, see, oxide is oxygen, married oxygen. They are now a Mrs. Okay, they are now a Mrs. Right, if the non-metal element is combined with oxygen, the suffix "ate" is added, right? So like carbonate, you see, because carbon is a non-metal, when they combine with oxygen, we just use the word "ate" instead of "I." So carbonate, because you see, calcium carbonate is CaCO3. Can you see the carbon, which is a non-metal, get married to the oxygen? So this part, we just call it a carbonate. This is a bit complicated already, right? If you don't want to understand this, it's okay. Completely fine. So if more than one atom of the non-metal element reacted with the metal, prefix is added. For example, carbon dioxide, di means two, sulfur trioxide means three. Okay, and then you have quadroxide and pentoxide. I mean, that is like 4 and 5 lah, but usually we don't mess with that. All right, so you just look at the name. Carbon dioxide, that means carbon, and with 2 oxygen, that means it's CO2. Right, that's the way it is. Guys, don't even get me started on this. Next time when you learn, you write iron oxide this way. You will write iron 2 oxide, and then there's iron 3 oxide. This is even more complicated, right? You'll learn this in year 9 chemistry. Okay, maybe not year 9, year 10 chemistry. You'll be learning this. Sir, why I got 2 types one? That's a completely different ball game, right? Do you girls like chemistry? Do you girls like chemistry? Usually girls will love bio, but not so much on chemistry. Physics is the absolute worst. Right? Physics and girls don't mix very well. That's the way it is, right? So when next time when we go physics, in a few more chapters when we go physics, yikes, right? That's how girls will get really bored out, which I understand, right? So this is the naming. So chemical formula for compounds. We learned that chemists usually refer to elements by their symbols. In compounds, chemists do the same. When 2 or more symbols are added together, we get a chemical formula, right? So this is what we write. Compounds are referred by their chemical formula. For example, sodium chloride is referred chemically as NaCl. Aluminium oxide, the one I said just now, the aluminium ore, is Al2O3. Right? I'm sure you must be asking, sir, why got 2 and 3 here? This depends on the charge. This one you will learn in year 10 next time. Because aluminium is a charge 3 plus. Oxygen is a charge 2 minus. When you pull both of them down, it becomes Al2O3. 2 you pull down, 3 you pull down. This is chemistry, right? Sir, what is this? You don't need to know, right? You don't need to know. I am just telling you. This is what you do when you deal with chemistry in full strength when you're in year 10 next time. Anyway, I digress. Okay, this is your advanced level already. Okay, I'm like teaching you kung fu. I'm teaching you the basic kung fu first before I teach you the advanced stuff, because you won't understand what I mean. Right, so this is a chemical formula. This is not in your syllabus, by the way, because you're not writing this. You are not. So don't worry. You're not writing this because it's advanced chemistry already. Okay, so we have done compound. We have done compound, so let me do a quick reminder. Element is one type of atom. Compound is two or more type of atom, and they combine chemically. And let's look at the third one. Let's look at the third one, which is mixture. So what is a mixture? What is a mixture? Same thing as a compound. It has two or more elements, but they have no friendship. They don't combine chemically, right? Mixture consists of two or more elements or compounds. They are mixed physically. Just now, it's mixed chemically. I have chemical bond. I become friends. Like this thing, I have chemical bond. You see, there's a bond. Let's say you're oxygen, your friend is hydrogen. You guys just become friends, right? You guys have that bond. You guys have that connection. But now, mixture is like you guys sit next to each other. For example, sand and salt. You guys just sit next to each other. Do you guys talk? No. Do you guys become friends? No. There's no friendship. There's no bond here. So in this case, we call you a mixture, right? No friendship, no getting know getting know of each other, no nothing, right? You guys just sit next to each other, not talking, not knowing anyone. So that's your mixture, right? So different from compounds, although atoms or molecules are mixed together, no chemical reactions take place, right? So no chemical bonds are formed. Like I said, no bonds, no friendship, no new substance. No new substance. You see, you take sand and salt, you shake them together, they still look like sand and salt. It's just that they're mixed together. So do you get anything new? Do you see anything new coming out from it? No. No. You see, just now sodium, explosive, chlorine, poisonous, you mix, you become salt, which is that white color crystal, completely different from sodium and chlorine. This one, they just look the same. They just look the same. There's no difference or anything, right? This is the boring one lah. So for example, water and oil. Can water and oil mix? No. Can water and oil become friends? No. Salt and sand? No friends. Gases in the atmosphere? Nitrogen, oxygen, or carbon dioxide? No friends. Guys, do you know we have many types of gas in the air? Right? Have you guys learned this before? Have you guys learned this before? Guys, I don't know whether you learned this in geography or science before lah. Huh? Do you know how many percent of nitrogen is in the air? Do you know how many percent of nitrogen is in the air? I mean, this is not in your syllabus, but it's good to know. It's good to know because next time in chemistry, you're learning it too. Guys, how many percent of nitrogen is in the air? The air you're breathing in right now has nitrogen. How many percent is it? No one knows? No one knows? Right? You have 78% of nitrogen in the air. That means this 78% you just inhale in. Sir, then what is it going to do to me? Nothing, right? You are just inhaling that nitrogen and you're just exhaling it out. You're not doing anything to it because this nitrogen has no function, right? Not to you lah, but this is for plant. What about oxygen, guys? What about oxygen? Do you know how much oxygen is in the air? No one knows? No one knows? How much oxygen is in the air? I mean, next year when you're learning lungs, you'll be learning this too lah. So how much oxygen is in the air? You have 21%. You have 21%. Right? Fun fact, guys. Fun fact, according to scientists, if oxygen were to go up to 30, if oxygen were to go up to 30%, we will all be so much taller. Right? We will all be so much taller. So next time, when people laugh that you are short, right? You can blame it on the oxygen. If I have more oxygen, I'll be taller. Right? But that means cockroaches will be bigger too. Are you okay with that? Are you okay with that? Hey, back when the dinosaur eras, back during the dinosaur eras, there are like 30-something% of oxygen in the air. So cockroaches used to be as big as your forearm. Cockroaches used to be this big. Imagine a cockroach of this size flew into your house, you would faint, right? So thank God that oxygen is low. I can live with that, right? So next, carbon dioxide, we have like 0.03% of carbon dioxide in our air. Guys, all these numbers I'm just telling you for fun, it's not important, just letting you know, right? So your atmosphere gas is mixture also, because will nitrogen and oxygen become friends? No, they don't. Will oxygen and carbon dioxide become friends? They don't too. Will nitrogen and carbon dioxide become friends? No, they are each on their own. Right? It's like three guys sitting in a room, not getting know to each other, not knowing each other. Right? Let's say you are nitrogen, your friend, another oxygen is in the room, and then another guy called carbon dioxide in the room. They just kind of chill there, not talking to each other because they don't know each other also, right? And of course, milk. Inside your milk is actually a mixture of water, sugar, fat, protein, vitamins, minerals. They are also each on their own. No friendship, no knowing each other, none whatsoever, right? And of course, guys, do you know what is alloy? Have you guys learned this before? Have you guys learned alloys before? You will learn this in chemistry in year 10 actually, if I'm not mistaken. Guys, do you know what is alloy? Any of you here know what is alloy? Any of you here know what is alloy? You know what is alloy? Alloy is a mixture of two metals. Okay, alloy is a mixture of two metals. Right, for example, bronze, you know what is bronze? Bronze is 青铜. 青铜, bronze. Bronze is a mixture of copper and tin. 就是拿铜加锡，你就会拿到青铜咯。So that is a bronze. Right? Like for example, steel is a mixture of carbon and iron. Carbon is 碳, iron 就是铁咯。碳加铁你会拿到什么？你会拿到钢。Right? Steel. So your stainless steel is made from iron. So you just melt them together. Are they friends? No. You see, this copper and this tin, they don't know each other. They just sit next to each other. There's no friendship, so they just kind of become bronze. So this is a bronze law. Okay, mineral water is a mixture also because you have water and minerals all inside. Coffee is a mixture because you have beans and water. Air is a mixture of gas, water vapor, dust, and microorganism. Sea water is a mixture of water and mineral salt. All these are mixture. No friendship, no chemical bonds, no getting known to each other, nothing. Right, guys? So today our main point, is element, compound, and mixture. Right? Element is the simple one. Element plus element in a chemical way is your compound. Element plus element in a physical way, they don't become friends, they are your mixture. That's all you need to know. Right? You guys cool? You guys cool? Sitting, I think you're okay, because you learned this before already. Is it the exactly same as your school? Is it the exactly same as your school? I don't know why, some school, including even Cambridge syllabus, Cambridge, they combine, they split this into two chapters. For some reason, okay, I think compound and element is in one chapter, then mixture they put into another chapter. For me, I don't see the point. I just put them all together because they're the same thing. Right? They're the same thing. So this solution thing, okay, I'm not going to talk about this today. Let's do some exercise for today. Let's go to page 21. Okay, Sitting, I don't think you have this notes because if you register in June, you should receive the June notes. But unfortunately, this May note I haven't finished, so you have to look at my screen for now. Right? Or if you want the soft copy, you can come and get it from me, no problem. Right, so number one, matter is made up of particles known as atoms. The diagram below shows the basic structure of a helium atom, right? What is a helium? Helium is the second lightest element in the world. It's a type of gas. We use this to fill our balloon. right? So something is missing here, guys. Please put a plus here. The darker color ball, please put a plus here. Right, so what is X? What is X? X is the spinny one going around. This is your electron, and they are negative, remember? Electron. And your Y is positive. This is your proton. Okay, if you remember this. And then the Z, this one has no charge one. This is what we call neutron. This guy has no charge. Neutron has no charge. Right? They are not positive, they are not negative, they are just there. Right? Do not get this wrong, guys. Do not get this wrong in exam. They are incredibly straightforward, incredibly easy. So B, state the subatomic particles located in the nucleus of the atom. Now, what is subatomic particle? Subatomic particles are these three lah. Okay, we call them subatomic particles. And which one is in the nucleus? Nucleus is in the middle, right? Nucleus is in the middle. So who is in the middle? That would be your proton and neutron. Electron, they are spinning around. They are going around your atom. So this is proton and neutron. We'll talk more about this electron when we talk about electricity. Have you guys learned electricity before? Have you guys learned electricity? Have you guys learned it? Electricity is when electron they flow. That is a completely different topic for another time. Right, C. State the subatomic particles which has the following property. Who has no charge? That would be your neutron. Neutron is no charge. Negative charge is your electron. Right? It is negative. Positive is your proton. Because pro is positive. Able to move is your electron. Your electron can move. Your electron is going around. Okay? You guys okay? Do slow me down if you're not okay. So number 2, Zubair drew an empty periodic table in his exercise book. What is the periodic table? Okay, it is a table consisting of all types of elements. Right? It is a table that has all 118 types of elements. Right? No compound here. There's no compound here. There's only element. So you don't find water here. Guys, sir, where is water? There's no water in the periodic table. Water is a compound. It's not an element. We used to believe it's an element. In fact, guys, we used to believe there's only 4 types of element. We believe that there's only earth, wind, fire. What else? Earth, wind, fire, water. Yes, the 4 types. You know, when you play games, the 4 elements, right? You guys watch Avatar, The Last Airbender. Okay, that thing lah. Right, so B, identify the location of metals, semi-metals, and inert gases. Right, I think I told you guys this before. Okay, metals are all on the left side. Right, so let's use green as the metal. So metals are all on the left side, which is here. Here, and here. These are all metals. Okay, be careful of this box here. This top here is not metal. This is not a metal. This guy is in fact hydrogen. Hydrogen is not metal. Right? And your half metal, semi-metal is this one. 1, 2, 2, 2. Oh shit, I missed a box here. Okay, just remember as 1, 2, 2, 2. This is your half metal. Okay, your semi-metal. That means they behave half like metal and half like non-metal. Can they conduct electricity? Half. Can they conduct heat? Half. Are they hard like metal? No, but they are half as hard. So these elements they are kind of weird. They're kind of weird. It's just like these are guys, these are girls, these are half guys, half girls. If it makes any sense. right? So where is your inert gas? Inert gas is at the last group. These gas they are so antisocial, they won't mix with anyone. They are just kind of alone. They just sit at the last row of the class. They don't mix around. They don't become friends with anyone. Okay, so we just call them inert gas. They're the boring ones. They don't react, or they don't create any color, any interesting reaction. No, they're just boring, right? You burn them, you add acid, you add alkaline, you do anything to them, they will not react. They will not give you any reaction, right? So which is which? P, where is P? P is here, I think. Yeah, P is here. So P is our inert gas. Okay, and then Q and R. Q and R, they are your non-metal. Okay, they are your non-metal. And then S and T, they are your metals. Yeah, your metal column. As you can see, guys, as you can see, I will not, no one ever will ask you to memorize the periodic table, right? You just need to know where is the metal, where are the metals, where are the non-metals, where are the semi-metals, things like that, right? There is no need for you to memorize the table, Please do not do that. Don't waste your time, right? Unless you just like them and you want to memorize them, then hey, okay, sure, go ahead. Good for you. Right, compare and contrast S and Q. Compare means they want the similarity. Contrast means they want the difference. So what's the similarity between S and Q? Between S and Q, S is a metal, Q is a non-metal. They are both elements, right? They are both elements. They are both the simplest thing in the world, right? The difference, I mean, try not to use this thing lah, If you say S is metal, Q is non-metal, the answer is already here. So try not to make it so obvious. Right, you can say S is shiny, because metals are shiny. Q is dull, right? Non-metals are dull, like charcoal. Charcoal is a non-metal, so charcoal is dull. They are not shiny, right? So you get what I mean? Next, number 3. The diagram below shows the arrangement of atoms of two types of matter. You see this one, this is all the same type. Obviously, this guy is an element, and this is obviously a compound. Because you see there's two types here. So label water and iron. So this is the iron. Because it's an element, this is water. Because water is a compound. Right? You guys following so far? You guys following so far? Please let me know if you're following. Please let me know you're following. Right, so next, moving on. Determine whether water and iron are the element of compound. Yeah, this one you already know lah. Water is a compound. Iron is an element. Right, next. Based on the element and compound you have stated in 2B, explain why the substances are classified as element of compound. Why is iron an element? Because iron is made up of one type of atom. Right? What about water? Water is made up of two types of atom. Right? Two or more, we call it a compound. Right? So water is a compound. Okay? I would assume this is very easy, I'm just going to keep going, So D, the diagram below shows the arrangement of atoms for P and Q. So obviously you can see this guy is an element because both are N, the same. This is obviously a compound. because it's N and H. There's two types here. So whether it's element or compound are there, they're asking for it already. So this is a compound. This is an element. Justify your answer. Okay, why do you think it's a compound or an element? P is made up of two types of atom. Hiya, same answer lah. What about Q? Q is made up of one type of atom. This dot dot means you copy the top. I am lazy to repeat the same answer, so I'm just gonna write it this way. Right? So let's do one more, shall we? Let's do one more before we call it a day. So choose the correct word from the list to match each description. A substance made up of only one type of atom. So that's an element. Right? Number B, the tiniest particle of an element that can exist. What's the smallest thing in the world? That's your atom. Right? C, a group of atoms bonded lightly together. A group of atoms bonded together. Okay, before you say it's a compound, no, it's not. It is a molecule. Right? It is a molecule. Right, a substance made of more than one kind of atom. More than one kind of atom. That is a compound. Right? A column in the periodic table, a column is called a group. Okay, a row is called a period. Right, before we get confused, guys, I have a lot of students who get confused. Guys, sir, atom and molecule, how is it different from element and compound? Right, let me explain. Atom is one. 一粒 atom 是一粒 atom is one. Molecule is more than 一粒多过一粒 and then element is 一种 one type. Compound is more than 一种 right? So atom and molecule is about the number. Element and compound is about the type. Get what I mean? Get what I mean? So you see, you can say water is a molecule. Okay, water is a molecule. 因为水有多过一粒 Water has three, right? You see, water is H2O, right? Okay. Water is a molecule because it's more than 1 Vg. 多过一粒 is more than one ball. Water has 3 balls here. So it's more than one. Water is also a compound because water has more than one type. You have O and H here. Right? If it's oxygen, okay, let me give you another example. If this is oxygen, oxygen is O2. The oxygen in the air, the one you breathe in right now, that's O2. O2 is like this. Okay, one O becoming friends with another O. So this one is a molecule because it's more than one 多过一粒 so 它是 molecule. But this is an element because there's only one type. You see, O2 oxygen is a molecule but it's an element, right? So these two are different. Atom molecule is about the number. Element compound is about the type. So don't get confused here. Don't get confused here. It's two different things. Right? They are not related, They are completely unrelated. Each is on their own. Okay? So, you guys cool? You guys cool? Sitting, I think you learned this before already, I hope this lesson didn't bore you out. I hope this is not too sian for you. I know you learned this already. Okay, just treat it as a revision because it's still coming out for your finals. Right? So, you guys have any question? You guys have any question? Sinting, you have any question? Although it's your first lesson here. Next week I shall wrap this chapter up, hopefully, right? And hope we can go to chapter 9. We'll see how. Right? Because most people are not here today, so I can't go too fast because next week I'm going to repeat again also, right? For people who are not here. Right. So if you guys have no question, okay, if you guys have no question, I think I'll end my class here lah. I hope you have a great Monday. Okay, have a great holiday. I'll see you next Monday. Right. Have a good one, guys. See you next week. Take care and good night. Bye.